Camera, did you check? Are you sure?
Yeah.
Okay, in this video, we're gonna learn how to apply the distance formula. So first let me write down this formula right here. Let's say I'm gonna write down right here. So D equal R times T. So R times T. So everyone knows D is what? Distance, R is what? Rate, and T is what? Time. So let's read this problem together. Air travel. So an aeroplane flew for 5 hours with a 25 km per hour tailwinds. So tailwinds mean with the wind. So we are getting help from the wind. And the return flight against the same wind. So the return flight against the same wind took 6 hours. Find the speed of the aeroplane in still air. The hint is distance is the same both sides. So let's set up the first problem. So the hint they give us, distance is same, so we're gonna write down, let's say D1 equal D2. Okay, so let's say we are flying from Boston. This is our Boston, and then we are flying to London. So Boston to London. So okay, London. So we are flying to London, let's say with the wind, tailwind. So in that case, we're gonna get help from the wind. So, and then we are coming back, we're gonna come back against the wind. Okay, so we set up the problem. So from Boston to London we are going against, so we're gonna call D1. Okay, so we're gonna use same formula, R times T. So R times T. So rate is what? Since we don't know the speed of the aeroplane, we're gonna call X. So X is the speed of aeroplane, and we are going with the wind. So with the wind, what it means, we are getting help from the wind, which is a 25 km per hour. So I'm gonna write down here X plus 25 times with what? T. T is what? Took us 5 hours. So value of the T is a 5 here. So my D1, let's calculate D1. So my distance 1 gonna be, I'm gonna distribute here inside, which is what? 5x plus 25 times 5, which is what? 125. So 125. So okay, you could use even calculator. So 125. Okay, so that's my D1. So let's calculate D2. So I'm gonna calculate D2 right here. So D2 is right here. So we're gonna use same formula, R times T. So this time we are coming back from London. So my D2 R is what? Again, we don't know speed of the aeroplane, and in this case we are heading against the wind, so I'm gonna minus 25 here because wind is pushing us backward. So it took us what? 6 hours. So let's calculate D2. So I'm gonna distribute 6 inside here. So this is gonna be what? 6x minus, so 25 times what? 6, which is 150. So let's do 150. So that's my D2. So now problem is very easy. We know the distance is the same both sides. So we're gonna call here D2 equal D1. Okay, so for D2 we just got 6x minus 150, and D1 is we have 5x plus 125. So now variable one side and constant one side. So let's move 5x other side. So this side is what? Positive 5x, other side going to be negative. So we have already 6x this side minus 5x and 125 here this side, and I'm gonna move 150 other side. So this side is what? Positive, sorry, negative, other side gonna be positive, so 150. Okay, so 6x minus 5x, which is gonna be x, and 150 plus 125, so which is 275. Okay, so 275. So speed of the aeroplane is what? 275 miles per hour. So we could say write down, let's write down here anyway, x. So x is the speed of the aeroplane. So okay, so unit rate we have given kilometer actually, so we're gonna call kilometer. 1 second, let me erase a little bit. So we're gonna say the speed of the aeroplane is per hour. So that's it. This is our final answer. So good luck watching this video. We'll see you in the next video.